Number 1. A 26.1 kilogram marble is pulled horizontally 47.2 meters along a frictionless pine floor with an applied force of 20 newtons. What is the acceleration of the block? First, we are going to draw a force diagram. We have an applied force, a normal force, and the force of gravity. Then we're going to create our force equations that go with each direction. You're going to do this every time you draw a force diagram. So here, I don't have any forces at an angle. I also have two forces in the y direction, the normal and gravity, force of gravity. So N minus Fg. I have one force in the x direction. And so each of these are the sum, or the net force, in each direction. And according to Newton's second law, right, F net equals ma. So this equals ma. This equals, that's a in the x direction. It's going to be ma in the y direction. But for the majority of our problems, all the problems that are on something being pulled horizontally, this is going to be 0. So we're looking for what the acceleration is. So now we go back to the original problem and look at the numbers that they gave us. The mass of the marble was 26.1 kilograms. The applied force was 20 newtons. Now they gave us a distance of 47.2 meters, but it doesn't seem like we need that at all for this problem. So we don't need to worry about that because it's asking for the acceleration. So we're going to take the x force here, and we're going to set 20 equals 26.1 times acceleration. So A is 20 over 26.1. And when we solve for the acceleration, we get 0.77 meters per second squared. Problem number 2. A toy chest of mass 18,050.4 grams is pushed along a floor with a force of 78.5 newtons to the right. If the force of friction is 12 newtons, what is the acceleration of the chest? So the first thing I have to do is convert this to kilograms. Divide by 1,000, so 18.0504 kilograms. Force diagram. There is an applied force. There is a frictional force. Normal force. Force of gravity. Now, force of gravity, remember, is equal to mg, mass times gravity. In case you want to know what the normal force is, that is how we're going to need this equation in the future. So, next step, F net x, F net y. I have 4 forces here. 2 in the x, 2 in the y. None with an angle, so I don't have to worry about cosine and sine, but we're going to write the equation for both. Friction is always negative, so applied minus friction, N minus Fg. This is going to equal ma. F net equals ma. This will be ma in the x direction. Again, ma in the y direction, but as I previously said, 0 in the y direction. So now we're just going to use the numbers they give and solve for acceleration. Notice I don't put any numbers in before I'm ready to start solving. This way, when you're given problems that don't have numbers, you are used to writing out variables first. So the applied force was 78.5. The frictional force was 12. The mass over there is at 18.0504 and times acceleration. So 78.5 minus 12 is going to be 66.5. Divide that by 18.0504 and we get our acceleration. And so our box is accelerating at 3.68 meters per second squared. We're going to skip all the way down to number 8. A 70 kilogram box is pulled along a horizontal floor by a 400 Newton force. That is applied at an angle of 30 degrees above the horizontal. Oops. Go back and change that then. A kinetic frictional force, so there is a friction. The word kinetic just means it's moving. A kinetic frictional force of 75 newtons acts on the box. So this question wants to know how far does the box move in 3 seconds, assuming it started from rest. So when you deal with problems, when you see problems that have like velocity, seconds, distance, you should start thinking about using a Zatvov at some point. And this particular question wants to know how far does it move in 3 seconds, assuming it starts from rest. So if looking at our Zatvov, we're missing one of the givens that we need. And we use Newton's second law up here to solve for acceleration. So once we have the acceleration, then that's going to go right here, and then we can solve for distance. So we write our F net x, F net y. So here I have 3 forces that don't have an angle. So normal force doesn't have an angle, force of gravity doesn't have an angle, friction doesn't have an angle. Again, it's negative, but I do know that FA, the applied force, has an angle, and so there will be some of it in the x direction and some of it in the y direction. So there's some of this that's going in the x here. That's going to be FA cosine of theta. And there's some of it that goes here, and that's going to be FA sine of theta. And it's in the same direction as the normal force. They called the normal force positive, so then that's positive. So F net equals MAX, MAY. You'll get to the point where you just recognize there's not going to be an acceleration in the y direction and leave it out. But for repetition and practice, just keep writing it and then cross it out. And so this is our acceleration that we're solving for. So now we can plug numbers in. We're going to take that equation and start plugging numbers in. It's a 400 Newton force, so 400 cosine of 30 minus 75 newtons equals the mass, which was 70, times acceleration. So 400 cosine of 30 minus 75 is 271.4. Divide that by 70, and we get an acceleration equal to 3.88 meters per second squared. Now we're going to take that number goes right into here. We don't have v final, so now we're going to use one of our famous 4 equations to solve for distance. Started from rest, so that's 0. So x equals 1/2 of 3.88 times 3 squared. So x equals 17.46 meters. Hope this helps.